This is a video for Honors Algebra 2 in our Quadratics unit, Unit 2. The student learning topic is I can rewrite a quadratic equation from standard form to both factored and vertex form. But first, a warm-up. We're going to solve using the most efficient method. Two of these will factor. One is a complete the square and one is a square root method. So I'm going to start with the square root method because I can see number 3 is clearly the square root method. We need plus or minus root 7. Subtract the 3 to the right. X is negative 3 plus or minus root 7. For my others, I'm going to get these into standard form so I can decide what is going to be complete the square versus what is going to be factoring. So looking at my equations, these have a leading coefficient that's not 1. So I'm pretty sure these are going to factor. And that would leave number 1 to be complete the square. And B is even, so I am going to complete the square for this one. Half of negative 10 squared to both sides. Factor the left. Combine my terms over here. Square root. And then add 5. X is 5 plus or minus root 6. So 2 and 4 factor with a leading coefficient of 3. First, I'm going to check, always check first, greatest common factor. Can all 3 terms divide by the same value or same term? No, there's no greatest common factor, so I'm going to factor with split the middle or box method. So 3 times negative 8 is negative 16. All the ways to multiply to 16. Rewind. Wait, it would help if I multiplied correctly. That's a blooper. Okay. 3 times negative 8 is definitely negative 24. So we got 1 and 24, 2 and 12, 3 and 8, 4 and 6. To multiply to a negative and add to a negative, the bigger number is going to be my negative. And 2 and negative 12 are my pair. This one I'm going to do with box method. The other one I will complete the square. So we've got 3x squared, negative 8, 2x, and negative 12x. And filling in my factors. 3x squared has to be x times 3x, and I chose the 3 here because of the 12. That makes negative 4 there, which makes it 2 here, and 2 times x is negative 2. That works. 3x plus 2, x minus 4. Set each factor equal to 0. X equals 4 is one of my answers. Solving this one, I'm going to get 3x equals negative 2. Divide by 3, negative 2/3. All right, for 4, I'm going to split the middle. If you like box method, you do box method. Again, with the the negatives, negative, negative, negative. We're going to choose this pair. So 2x squared plus 3x minus 6x minus 9. Greatest common factor of each half. Regroup it. Set each factor equal to 0. X is 3. X is negative 3 over 2. And on to our objective today of writing a quadratic equation in all different forms. So at the top, you can see we have a summary of the 3 forms of a quadratic function. Standard form, that's when we have the ax squared, bx, and c. Vertex form, or some people call it transformation form, where I have my leading coefficient, the x-coordinate of the vertex, the y-coordinate of the vertex. Because in transformations, this would be right or left h, up or down k. And then factored form is when we use the x-intercepts, where we're given those x-intercepts. So the leading coefficient again, all these a's are the same value. X minus the x-intercept, x minus the x-intercept. So we're going to use all 3 of these as we go through this page. Consider the equation f of x equals x squared minus 8x plus 12. Complete the square to go from standard form to vertex form. I'm going to rewrite this with a y. And for complete the square, I need to move the constant to the other side. And now complete the square. So I'm going to add some value to both sides. Half of negative 8, negative 4, square it, 16. So on the left, we've got y plus 4, and a factor to the right. Then I want to get the y isolated. Y is x minus 4 squared minus 4. Just for fun, I can identify where the vertex would be. The vertex would go right 4, down 4. Leading coefficient is 1. Same here, it's a 1. Now factor the equation to go from standard form to factored form. So again, I'm going to start with my original standard form. And let's factor. What multiplies to 12? That adds to negative 8. Because it's a positive 12 with a negative 8 in the b, both numbers would be negative. So we're going to use the 2 and the 6. So x minus 2, x minus 6. Graph the standard form of the equation in your calculator or Desmos. I will use my calculator. Oh, I kind of got ahead of myself at the top there. That's okay. What is the vertex? So I'm going to trace. I'm going to get my cursor over here. Oh, look at those decimals. It won't go exactly. So if I hit trace negative 4, because I know of that transformation, it shows me a point all the way over here. Come on, Miss Weiss, get it together. It's not negative 4. This is positive 4. Trace positive 4. Whew. All right. X is 4. Y is negative 4. What are the x-intercepts? Looks like this one's at 2, so I'm going to go trace 2, enter. Yep, sure enough, 2, 0. So 2 comma 0 is one x-intercept. This one over here, let's see, 3, 4, 5. Let's see, trace 6, enter. Yep, that's the other x-intercept. And here's the pretty picture from Desmos, hiding off on the side, to support exactly what we just got. For what values of x does the function equal 0? So if I take my standard form and set that equal to 0, well, we would solve this by factoring. Set each factor equal to 0. I get x is 2, x is 6. Check it out. X is 2, x is 6. That's the solutions we got here. Any value of x where the function, where the y value is 0, is called a 0 or a root. Those words are used interchangeably. Zeros and roots mean the function equal to 0, these x-intercepts. What connection do you notice among the factors, the zeros, and the x-intercepts? They're all the same. It's kind of just a summary of what I just verbally said. The x-intercepts, the roots, the zeros, and solutions are all the same, and they result from setting the factors to 0 and solving. Pause the video here to write that down into your notes. All right, we got another example on the next page. Complete the square to go from standard form to vertex form. And now, what is the vertex? So let's do that. I'm going to move the constant to the left-hand side. Complete the square. Half of -2 squared. Add my 8 and 1. Factor the right. Isolate the y. And the vertex is at the point to the right 1, down 9. After the equation, what multiplies to -8 that adds to -2? Okay, there's factored form. What are the roots? The roots are when the factors equal 0. Those are the x-intercepts. So x equals 4 and x equals -2. And a very funny, I guess, meme. They're all pointing at each other. Hint, they're all the same equation. All right, last one. Consider the function x minus 7, x plus 3. Complete the statements. Since x minus 7 is a factor, we see that 7 would be a 0, which means that 7 is an x-intercept. Because when does x minus 7 equal 0? That's when x is 7. Okay, let's do the other factor, x plus 3. So we see that -3 is a 0, which means -3 is an x-intercept. They're also called roots. Write the equation in vertex form. What is our plan to do this? Then state the vertex. Pause the video and think, what is our plan? How am I going to go from factored form to vertex form? Hopefully you thought that the plan would be step 1, find standard form. We're going to multiply our binomials together, and then step 2 is go to vertex form. All right, let's multiply. X times x, x times 3, negative 7 times x, negative 7 times negative 7 times 3. Don't forget your y. Combine our like terms. Okay, standard form. Now let's get vertex form. Pause the video, see if you can get yourself to vertex form. There is the completed square vertex form. So the vertex is at the point right 2, down 25. So your homework is page 27 and 28. Show all your work clearly and get that practice done.